Hey everyone, I am Chiranjeevi and welcome you all to my YouTube channel. In this video, you are going to create a basic Terraform setup along with me with code, and you are going to connect it with your AWS account as well. Before getting into the actual video, I need to cover few things, which is infrastructure, what is infrastructure and all, and what and why is Terraform required. So we are going to see what Terraform is and why we need that Terraform, and then we are going to have a basic setup and connection with AWS account. If you are already someone who knows what infrastructure is and what and why Terraform is, please feel free to skip to basic setup and connection with AWS account. And if you are someone who has a primary knowledge in front end, or if you are a new college student or a new fresher who don't know about anything about infrastructure, please watch the first two sections as well. If you already know those two, please feel free to skip to the third section to the timestamp mentioned in the screen. Well, let's start with infrastructure. So the dictionary meaning of infrastructure is the organizational structure. For what? For anything. Let's consider for an entity. So when you consider something, the organizational structure which is required for that is the infrastructure. For example, let's consider a city. So for a city to run smooth, the organizational structure that it requires are roads, footpath, uh, flyovers, etc. Right? So when you consider an office, the infrastructure that is required is a building, hardware, if it's a software or an IT company, the laptops, whatever the hardware it's required, and employees. All these things are required for an office infrastructure. Similarly, when we consider an application, a software application, the things we require include a server, a database, a caching system, networking, serverless functions, etc. If you don't know any of these, don't worry, I will explain whenever we use them in future videos, and a good reason to subscribe to this channel, because in the future videos whenever we use them, I'll explain them what those are things. And on a side note, we don't use everything in every application, only some of them are required in each of them depending on the situation and the architecture of the application. Well, now that we know about infrastructure, let's see what Terraform is. So Terraform is nothing but a tool. It's a tool which helps us in dealing with infrastructure as code. So we will just write code for whatever infrastructure that we need, that we saw in the previous section of the video. Whatever it is, it may be a server, it may be a database, it may be something else. We will write code for it, and Terraform will create those resources in the cloud. So most of the companies nowadays are using cloud. I know only Dukan which is using physical infrastructure in these days. Let me know in the comments if you know any other such companies which are using physical infrastructure rather than cloud. So this Terraform infrastructure as code is mostly useful when we are dealing with cloud infrastructure, because when we consider any cloud provider such as AWS, Azure, or Google Cloud, whatever, they provide a interface, a graphical user interface for their dashboard, and we can go into that interface and we can create whatever we want, we can delete whatever we want, we can do whatever we want. But trust me, it is only easier when there are like resources that you can count on your fingers. When you work in a company which is working from more than a year, if you maintain that infrastructure via dashboard, via user interface, trust me, you are going to go bonkers by dealing with that infrastructure. So you need a better way to deal with infrastructure, which comes with this infrastructure as code. Not just Terraform, there are other tools as well, but Terraform is one such tool to deal infrastructure with code. Now that we know Terraform is an infrastructure as code tool, let's see what code we write in Terraform. So Terraform uses something called HCL, which means HashiCorp, which is the company that created Terraform. HashiCorp configuration language. So we use this HashiCorp configuration language HCL to write Terraform code. This is a declarative language, so we don't write crazy functions, loops and all, although that is supported to some extent and we use them very rarely, but most of all times what we do is we just declare something that we want. Let's say we want a server, we just say that we want a server and Terraform takes care of it and it creates a server. Terraform will do that. So we just say that we want something with some kind of configuration and Terraform does that for us. That's why it's just a declarative language, because we just declare what we want. Let's say we remove this part of code. Let's say we remove this part of code in the code base, and what Terraform will do is Terraform will delete this as well. So if something is there in code, it will be there in real infrastructure as well. If it's not there, it won't be there in real infrastructure as well. Terraform maintains that. Let's see how it maintains that. When we write code, after the code is completed, we do something called as plan. Terraform plan. This will generate a plan which shows the diff. This will give some diff, like it will show if we are adding a new resource or if we are deleting a new resource or if we are updating the existing resource. Oh, I mentioned deleting a new resource, sorry. Deleting a existing resource. It will show that diff. If we are okay with the diff, what we will do is we will apply that plan. Otherwise we can cancel it as well. When we apply that plan, what Terraform will do is it will call the API of cloud provider, whatever cloud provider that we are using, AWS, Azure, whatever it is. So it will call the API of that cloud provider, which in turn makes changes in cloud. Whatever creation or deletion or updation, it will make it in the cloud. So Terraform does this. When Terraform does this, it will also create something called as state. This state is what that represents the actual infrastructure in the cloud. Whatever that is there in state, it will be there in the cloud. This state is stored somewhere called as backend. This backend can be anything, any system. It can be your local system, it can be any cheap storage in cloud such as AWS S3 or Azure Blob Storage, or it can be in Terraform Cloud. There is a tool called Terraform Cloud and we will be using it in this tutorial because it's easier to set up and there is a free version of it which is more than enough for any small size company and personal usage. So it's simpler to use, that's why I'm preferring that. Let me know in the comments that if you want the tutorial on how to set up with AWS S3 or Azure or in your local as well. I don't prefer local because only one person can work on it if you do it in local. If you want others collaborate with you on the infrastructure changes, then you need to use a remote backend. You may ask, hey, do we need to go through all these things just to create few resources, and why can't we use the dashboard itself in any cloud provider that they provide? If you are not satisfied with the reason that I mentioned earlier, there are two more reasons that I can share on why we need infrastructure as code. One is let's say you had to research a lot while creating infrastructure for a new microservice or a new project that you are working, and you created a few resources after a lot of research. While creating a resource via dashboard, it's not very straightforward. You have to go through a lot of options, you have to give a lot of configuration values, and you have to do a lot of things while creating a resource even via dashboard. And it's not that we know everything. We had to research and we did that, and after a month or two you had to do that again. And in this period I am sure that anyone can forget what they did 1 or 2 months back. They had to research again and do all those things manually again and again. This is a very painful process. Let's assume if we have done that in code previously, what we can do now is just simply copy the whole code that we wrote before and just paste it again and change few names and other configuration values that we require. As simple as that. You don't need to do research again. You don't need to create all those things manually by going on all the configuration values that you used before. And another scenario, assume that a new person joined in your DevOps team. You can't go through all the cloud and you can't share all the details regarding the current infrastructure status to that new employee manually. If you have that in code, what you can do is you can just give them access to that code and they can read the code and they can see what is the current status of the infrastructure in the company. And it's very easy for them to get started with your infrastructure and start contributing very early. So these are the two most valuable reasons that I can give you on why you need to start using infrastructure as code rather than doing things manually. Alright, enough with the boring theory part and let's get started with the actual setup. I hope people who skipped in the beginning has come back. Welcome back everyone. So you have to go to this app.terraform.io website, and I'm already logged in, and if you don't have already an account with Terraform Cloud, please create one. It is as simple as creating an account with Facebook. When you are logged in, I am assuming that it may prompt you to create a workspace already. If not, what you can do is you can create a workspace by clicking on create workspace here, and you when click on it, it will ask you whether you want to use it with version control or CLI driven or API driven workflow. Version control we don't want because we are not integrating it with any version control system like GitHub or GitLab. What we need right now is a CLI driven workflow, and API driven workflow can also be used with this one. So I'm clicking on CLI driven here and I'm giving some name. I'm giving it tutorial, and I'm just creating. I don't need to change anything here. It's created and we are here in the overview page of the workspace that we created. After this we'll come back here, and what we need to do is we have to install Terraform in your system. Depending on your operating system you can use whatever you want. I'm on Mac and I used Brew. If you are on Windows you can use Chocolatey, or I believe you can use Coop as well. So depending on your operating system, please install your Terraform in your local system. After that, what you need to do is you need to open your terminal. After you open your terminal, let me increase the size. Yeah, what you need to do is you need to first log into your Terraform account from your local. So the command for that is Terraform login, and when you do this, it will ask you if you want to do the actual login part, and type yes and click enter, and it will take you to the Terraform Cloud account in your browser. And what you can do is you can generate a token here, and you can give the expiry number of expiry days as well. You can give whatever name you want, description, and click on generate token. I already have a token. What it will do is when you click generate, it will ask you to copy the token, and copy that token and come back here and paste that token here and click enter, and that's it. You will be logged into your Terraform Cloud account from your local. After you are done with the login part, come to your AWS account dashboard. If you already don't have the AWS account, please create one and make sure you delete everything after you finish the tutorial, because it may cost you a lot if you forget it. So once you are logged in and once you are in the console, go to the search bar and type IAM and hover on this IAM part, and it will show top features, and click on users, because we want to create an IAM user which will give us some credentials which we will use to authenticate from the Terraform Cloud to the AWS account. Otherwise, Terraform Cloud, how does Terraform Cloud know which account to use for the creation of resources and everything? And how does our AWS account know to accept those changes? So we need to create some kind of connection integration between the Terraform Cloud and AWS account, and this IAM user will help us in achieving that integration and authenticating our Terraform cloud account to the AWS account. And now we are here in the IAM dashboard and we want to create a new user. Click on create user and name it whatever you want, and I am naming it Terraform. And we don't need to provide AWS management console access to this user, so we are not checking it. Click on next, and we don't want to add this user to any group, or we don't want to copy any permissions. We want to attach policies directly because we want to give it some kind of permissions so that our Terraform account can use those permissions to do things in our AWS account. So click on this attach policies directly, and we want to give the administrator access because this will give the every possible permission in AWS account to this user, so that our Terraform account can seamlessly create or delete or modify any resource that we create in our AWS account without any hassle. If you limit these permissions to few things, our Terraform cloud account can't create or manage resources outside those permissions. So I'm giving administrator access. Most of the times we give administrator access unless you have very strict policies that you can't. Click on next, and you can give tags if you want. I'm clicking create user and it created the user. And now click on the Terraform here and it will take you to this dashboard. And what you need to do is you need to create this access key, which gives us the keys that we need to use. I will delete these access keys after this tutorial, so please don't try to use those keys. Create your own ones. So I'm clicking on create access key here, and it's asking what's the purpose. The purpose for us is to use it for the third-party service. So here the Terraform is a third-party service, so I'm clicking on third-party service, and it's saying IAM users are not actually the preferred way to use for authentication. IAM roles are the preferred way to use for the authentication using OIDC setup. If you don't know what OIDC and how to set it up, I will show that in the next video. That's actually the preferred way to authenticate even with the Terraform cloud account as well. For the sake of the completeness, I am using the IAM user credentials here, but that is not actually the recommended way. The recommended way is to use without any credentials using IAM role and OIDC setup, which I will show in the next video. So please make sure you subscribe to the channel and also like the video if you liked it so far. And I am checking I understand the recommendation and I am clicking on next. Tag just give Terraform. Why am I always giving Terraform? Okay, create access key. Now save these access key and secret key somewhere because we need these things when we use it in Terraform cloud. Now what we need to do is we need to go back to the Terraform cloud account and copy this particular code. Here we have copy button, copy that code. Now we need to create one directory for our code. I'm naming it as TF. TF is fine for me. And now go into the TF folder. Now we will use this folder as our infrastructure as code repository, and you can name it whatever you want. What we need to do is we need to open our code editor here. Please open your code editor, whatever it can be, VS Code or whatever. Currently there are no files in this directory and I want to create one. I am naming it as setup.tf. Every Terraform file ends with .tf, and remember that all the code inside a single directory is considered to be as singular. No matter in which file you keep it, Terraform is going to consider everything as a single unit. So I am naming it as setup.tf. You can name it whatever you want. So I am clicking enter and I created this file, and here I will paste the code that I copied there. So what this will do is this will tell the Terraform that the backend that we are using is from the Terraform cloud, and the organization name is that name that I gave, Chiranjeevi Personal, and the workspace name is tutorial that I created before. Now save this file, and what we want to do is go back to the Terraform Cloud and go to variables here. Here there are no variables right now, and we want to add our variables which are the access keys from the IAM user that we created. We want to add those here so that our Terraform code can use those values while running the plan. You will see this thing in action and you will get more clarity then. Just add those variables now, and we want this to be as a environment variable, and the key needs to start with capital TF underscore capital VAR underscore name of the variable. So I want to give it as access key, and the value is this one. Paste it here, and you can, this is just ID, so technically you don't need to keep it sensitive, but it's a good thing to keep it sensitive as well. Just add a variable. This is fine. The thing with the sensitive variables is you can't see the value. You can just update it, but you can't see it. Add another variable and copy this first. I'm naming it as tf underscore var underscore access key secret, and in the value I'm giving the value, and keep it as sensitive, and don't forget to make it as environment variable, and I'm clicking on add. I'll delete this user, so don't worry about the value that I'm showing here. Click on add. Now that we have these two values, we will use these two values in our code, and you will see that in action. After adding those variables, come back to your editor and open the terminal and make sure you are inside the directory whichever you are using. And now what we need to do is we have to initialize our Terraform project in this folder. We have added the basic code, but we haven't initialized it yet. So what we need to do is we have to do the Terraform init. So this will initialize the connection from our local Terraform package what we installed to our Terraform cloud account. It's saying it's been successful, but how we can test it is by running up actual plan. So what we can do is we can do just Terraform plan. This will run a plan, and we can't apply it, and there will be nothing to apply actually, because we haven't added any resource yet. So just do Terraform plan, and what it will show is it will give you a URL which you can use to go to the actual Terraform cloud dashboard, where you can see what's running here, and it's saying plan is running, and it will finish very fast because there is nothing actually in the state and we are not creating anything. So it's saying plan finished. As you can see, the actual integration between our local Terraform package and the Terraform cloud is set up, and the actual thing is working. Now what we need to do is we have to add the code for AWS account, and we need to set up the authentication, and we need to test the setup as well. To integrate AWS, let's first go to Google and search for Terraform AWS provider, and you can open this Terraform registry link, and here you can see the documentation for the entire AWS provider and how you can use it and how you can integrate it and how you can authenticate it. So you can, as you can see here, you can create anything, pretty much anything in AWS using this provider. It will have the required documentation that you need, and first what we need to do is we have to do this thing. In the required providers, we need to specify the AWS, and what you can do is just copy this entire code up to here, and the last part, it's just creating a VPC in AWS. You don't need to worry about it. It's just creating just for the sake of example. So you just need to copy until this part, copy this, and go back to the code, go back to the editor, and what we can do is we can create another file here just for the sake of clarity. I'm naming it as aws.tf, or you can paste it in the same file as well. As I said earlier, it's same thing. You, even if you use a different file or you keep it in the same file for Terraform, it's just a single thing. For the sake of clarity, I'm creating another file, and I'm pasting the code that I copied earlier here. and save this, go to the terminal and do a Terraform init again, because we added code for a new provider. Whenever you make a change of the Terraform version, or when you add a new provider, make sure you do Terraform init, and whenever you add a module as well. We will see all those things in future videos, what the modules are and whatever those are. For now, what you need to remember is it's better to do Terraform init whenever you clone a repo or when you are making a huge change in your code, just for the sake of sanity. And Terraform will warn you if you don't do it, so it's not a big deal. So do a Terraform init, and as you can see, it's finding the HashiCorp/AWS provider, and it's matching the version, and it's installed as well. I am closing my terminal once so that my LSP can start working. As you can see, there were no coloring well, so since I did a Terraform init with the AWS provider, I should see better colors now in our code. See, the colors are good now. Earlier it was all white, now you can see better colors now. Yeah, now what we need to do is we need to set up the authentication, and let's go back to the provider. And as you can see, there is a tab called authentication and configuration. Click on it, and as you can scroll here and see, there are two things that we can use here. One is access key and one is secret key, and we'll use the same in our code as well. Go here and go to the aws.tf file and go to the end and add access key. I'm getting a suggestion, so I'm using it. What we will do is we will use a variable called access underscore key. Remember the name that we had given in the Terraform cloud. We have given tf underscore var underscore access key, and we will use the part after the tf underscore var underscore, similar with the secret as well. Come back here, go back, and we need a secret key as well, and use var dot access key underscore secret. Save this. As you can see, it's suggesting that there are no declaration found for access key and access key secret. That's because we haven't declared them yet. How do we declare it? Create another file called variables.tf. It is a good practice to have a different file for variables and actual code and the outputs. We will see outputs in some later video. We don't need them right now in this video, but we need a variables.tf file. Create it, and inside here what we need to do is we need to create a variable with the name that we mentioned there, which is access key, and it is of type string, and it's secret, so I'm giving it as secret equal to true. Another variable access key underscore secret, and it's also type equal to string and secret equal to true. Now save this file as well. Now if you go to aws.tf, it shouldn't show the error. Why is it showing the error? Now it's not showing. I just had to close the editor and open it again. My bad, it's not secret, it's sensitive. Is that true? Yeah, it's sensitive. Now there shouldn't be any problem. Everything looks fine, and what we can do is we can open the terminal and we can go to tf, and what we can do is we can run a plan. Let's do one thing. Let's create a resource first. Let's add a code for a resource, and then we'll try to create a plan and see if it's being tried to create that resource or not. Let's go to this code again, and we saw the example, right? It's trying to create this example AWS VPC. Just copy this code, and you don't need to know what VPC is, we just need to see if it's trying to create it or not. Let's go to the AWS code and go to the last and paste the code, and what it will do is it will try to create a AWS VPC with the name example. Save this file, go to the terminal and do a Terraform plan. What we can do is we can test if our code is valid or not using Terraform validate command. Yep, the configuration is valid, it's success, so we can do Terraform plan. This will give us a link which we can follow to see our plan. Let's see what happens. If it runs and if it's showing that it will create, then it will create. Yep, it's showing a diff and it's showing that it will create this AWS VPC with the name example with the CIDR block, this one. What we will do is let's try to create one and see if it's being reflected in the AWS console as well. Right now when we go to our AWS console and search for VPC, your VPCs, right now it shouldn't show anything because I haven't created anything. There is already one, that's strange. I guess I created this while testing, so don't mind this one. This one is the default VPC that you will also have in your account. Every AWS account will have a default VPC and we can create whatever we want. So this one I guess I created while testing before. So now what we can do is we can do a Terraform apply command. This will create a plan as well, but that plan we can apply it. Normal Terraform plan we can't apply it if we do with Terraform plan command, but when we do it with Terraform apply command, it will also create a plan, but we can apply that plan. So do that Terraform apply and wait for it to give us a URL so that we can follow. We don't need to wait here for the URL. What we can do is we can go directly here and we can go to runs and we can see the latest one being running here. You can click on it and we can wait until it's finished. It's running the plan, it's almost done. As you can see here, after it's finished, as you can see here, you have different options. You can add a comment or you can discard this run, that means cancelling the run. When you don't want these things to happen, you can discard it, but we want to confirm and see, so I want to confirm and apply. You can add a comment and click on confirm, or you don't need to. Apply is queued and let's wait till the apply is done. I guess it should be done fairly fast. Let's see. It's created and the ID is VPC and ends with E6C. Let's see if it's really created or not. Let's come here and refresh. As you can see, the VPC ID VPC starts with VPC and E6C, it's created. So our Terraform setup is working as expected. Please don't forget to delete all the resources that you created. What you can do is you can simply, as I mentioned earlier in the video, that if you remove the code for whatever thing that you have written and if you run the plan again, first save this file, go to the terminal again and run the plan, apply plan again, you can see that it will try to delete the resource which we have created, which makes sense, right? It's a declarative language. We declared that we want that resource earlier in the code and now we remove that code, which means that we are declaring that we don't want it anymore. So Terraform tries to remove that, which makes absolute sense, and I want to delete it because I don't want to be charged. And don't forget, like I did, to delete. I will delete this one as well. after I end recording this video. So yep, I guess this should be done. Yep, it's done. Come back here, refresh, and it should be gone. Yes, it's gone. I will delete this one as well. Don't delete this one, this is the default one. As you can see, it's a different one. Okay, cool. Well, that's it for this video, and make sure you subscribe to this channel to see that next video where I will remove this access key and secret key, and we don't use any token at all in the code, and we'll still authenticate to our AWS account using something called OIDC, which is OpenID Connect. So make sure you subscribe to this channel for that video, and also please like this video if you like the content. And my NeoVim skills, which are pretty zero because I'm a noob, so please don't think that I'm showing off. I'm just learning the NeoVim. That's an additional thing that you saw in this video. I guess that's it for this one. Let's meet in the next one. Bye bye.